In this video, I want to talk about testing claim about population mean using one sample. In order to test that claim, we're going to use a t-distribution. Requirements that we need. The sample should be a simple random sample. And number two, the conditions for the central limit theorem have to be satisfied, which means that either our parent population is normally distributed, or we can compensate. If not, then we can compensate by a large sample. The test statistic is gonna be calculated using this formula. Let's take a look at what it looks like. Here's the example that we're going to consider. An incubation period is a time between when you contract the virus and when your symptoms start. Assume that the population of incubation periods for a novel coronavirus is normally distributed. By surveying randomly selected local hospitals, a researcher was able to obtain the following sample of incubation periods of 10 patients. So we have a string of 10 numbers. At a 5% significance level, test the claim that the average incubation period of the novel coronavirus is less than 6 days. Okay, so as usual, let's first identify the claim, the null, and the alternative hypothesis. So the claim again is easy to identify because it is preceded by the word claim. Test the claim that, here's our claim, the average incubation period of the novel coronavirus is less than 6 days. Now the question is this a claim about what? Proportion. We have options for proportions, mean, or standard deviation / variance. Well, the word average tells us that the claim is about the mean, right? The mean or average is less than 6 days. So claim is mean is less than 6. Again, let's set up the null and the alternative hypothesis. Where does this go? Does this claim go into the null or the alternative? Well, since it doesn't have a equal sign, it should go into the alternative, which is good because that's what we can only prove the alternative. We cannot prove the null. Okay, the null goes in with the equal sign. We're going to use the same expression, just change the less than sign to the equal sign, and that's your null. All right, so significance level. This is 5% significance level. So alpha is 5%. We finished the setup. Now we're going into the test statistic, calculating the test statistic. So we're going to use our sample data. Here I copied the formula for calculating the test statistic. And we need a mean from the sample, and we need the mean from our claim, and then we need the standard deviation from the sample and the size of the sample. So we need 3 values from a sample. So we're gonna use our StuckCrunch to calculate those values. I put in our sample values into the first column and calculated the mean and standard deviation. I got the mean of the sample is 5, and the standard deviation was 2. N is 10, of course. So I can use these values now to calculate my test statistic, to put it into the formula. Let's do that. So T equals X bar minus the mean of the population. We're testing it, so it's going to be the mean from our null hypothesis, which is 6. And then standard deviation of the sample is 2 divided by the square root of 10. So just like in with the previous problem, I recommend calculating the denominator first and then the rest. So putting everything in the calculator gives me negative root of 10 over 2. And converting this to decimal will give me negative 1.58 approximately. So I'm gonna round it to, let's round it to to three decimal places. Usually z value is rounded to 2 decimal, and everything else, the t and chi-squared is rounded to 3 decimals. Traditionally, it comes from using the tables, which we're not using right now, but that's where it came from, where that tradition came from. But anyway, so that's what we're gonna do. Now we need to find the p-value or critical value. Both of these will come from our t distribution. Before we get there, though, I want to draw a picture that represents our situation, illustrates it. So we are assuming that the mean is 6, so we have 6 in the middle, and we're trying to prove then mu is less than 6. So this is going to be a left tail test, and my alpha is a 0.05. So this region on the left side, it's equal to alpha, and it's 0.05. So now let's go ahead. For the p-value, we're going to find the area on the bottom that corresponds to our test statistic. And if we're using the critical value, we want to find the t-value that separates these bottom 5%. That's what the critical value is. Let's find both. Again, we're gonna use our StuckCrunch, and we're gonna select a t distribution. For the testing of the means, we are gonna use the t distribution. And the degree of freedom is 9 because n is 10. All right, and we're looking at the left tail, and our t, the test statistic that we found, is negative 1.581. Okay, so that area to the left of that t-value is 0.074. That's our p-value. So the p-value is 0.074. Okay, and while we're here, let's find our critical value. For the critical value, we're gonna put our area of 0.05 into the probability field, compute. So the critical value is, so CVA is negative 1.833. So what does that mean? Let's take a look. Okay, so the the t-value, well, first of all, if we're just using the traditional method, where is this critical value? It is right here. Again, that's the value that separates the bottom 5%. That's negative 1.833. Okay, compared to that value, where's our test statistic? The test statistic is negative 1.58, so it's going to be slightly on the right-hand side of my critical value, right? So maybe right here, we're going to say t is negative 1.581. That's my test statistic. So as we can see from this picture, our test value did not land far enough, right, from that center value. It landed on the left side, but it didn't land far enough. So what is the p-value then? That's the area under the curve cut by our test statistic of negative 1.58. So what does that mean? That's the probability value of this test statistic occurring by chance if the true mean was really 6. Could we get a mean of 5 in a sample of 10? Yes, and the probability of it is not very low. It's actually not an unusual event, is what we got from this all. Okay, so what's the conclusion then? The conclusion is we did not have enough support for our alternative hypothesis, so we cannot reject the null. So do not reject the null. All right, what does it tell us in terms of our claim? So the claim was that the average incubation period of the novel virus is less than 6 days. So, and this was our alternative. We did not gather enough evidence for it. So this is what we're going to say in our interpretation. We're going to say at a 5% significance level, we cannot support the alternative hypothesis or the claim. Okay, so here's the formal wording. At a 5% significance level, we do not have sufficient evidence to reject the null hypothesis in favor of the alternative hypothesis. But I mean, you still have to say something about the claim. And so that would be that we did not get enough support for this claim. And ideally, you would restate the claim that we did not have enough support to say that the average incubation period of the novel coronavirus is less than 6 days. So this is it. This is how you do it. Let's take a look at the next one, the test hypothesis about population variance.